Hello, welcome to Maths with EJD. In this video, I'll be talking about arithmetic sequences. In the previous video, I talked about introduction to sequences generally. So we introduced ourselves to arithmetic, geometric, and other sequences like Fibonacci and harmonic, actually. So here, I really want to go deep to talk about everything relating to arithmetic sequences. All right, so let's see that the definition, first of all, like we already know, but just to reiterate this. So an arithmetic sequence is a sequence of numbers where the difference between consecutive terms is constant. Okay. Now, this constant difference is called the common difference. And it is represented by small letter d. All right. So now let's focus a bit more on the common difference. What is it really about? Okay. So the common difference is the amount by which each term increases or decreases from the previous one. That's why I said arithmetic sequences just involves continuous addition or subtraction. So you have constant increase or constant decrease. Okay. The common difference is the amount by which each term increases or decreases from the previous one. And then it can be calculated. It can be calculated by subtracting a term from the next. So in essence, uh, if we have a sequence an, which is such that we have a1, a2, a3, and so on. Okay. The common difference is simply a2 minus a1 or a2, a3 minus a2, and so on and so forth. Okay. And that simply means that uh, generally, uh, so what that means on a general term is that D is an plus 1 minus an. That is how you get the common difference. Okay. Now, so of course here now, an plus 1, of course, an is the nth term, like we know already, and an plus 1 is the next one after that. Now, the next thing I like to do, which we had actually done in the previous case, is to show how to find the nth term of an arithmetic sequence. So I think I'll have to explain that again. So finding the nth term of an arithmetic sequence. Finding the nth term of an arithmetic sequence. All right. So the other time I gave two examples. I had 2, 5, 8, and so on and so forth. 2, 5, 8, 11, 14, 17, and so on. Okay. So given this, right, you can imagine that the first term, A1, is 2, the second term is 5, the third term is 8, the fourth term is 11, and the fifth term is 14. So let's stop here. So you see, this is just 2, right? And this is 2 plus 3, and then this is 2 plus 3 plus 3, and this is 2 plus 3 plus 3 plus 3, and this is 2 plus 3 in 4 places. So you see the number of twos you have is one less the number of the position. So for one now, you have 0 threes. For two, you have 1 2. For three, you have two twos. For four, you have three threes. For five, you have four threes, right? So that means that we have, this is going to be something like 2, 2 plus 3 times 1, and this is 2 plus 3 times 2. This is 2 plus 3 times 3, and this is 2 plus 3 times 4. All right. So interestingly, it means this is just 2 plus 3, uh 2 plus 3 times 0. Okay. Now, if you look at the way it's going, that simply means that we have something like 2 plus 3 times n. N is this position now, the position of the term n minus 1. And of course, this is also, so this is, okay, not too fast yet. 0 is 1 minus 1. That's what I meant to write. Plus 2, I mean, and then this next one is 2 plus 3 into 2 minus 1. This is, 2 plus 3 into 3 minus 1. And this is 2 plus 3 into 4 minus 1. This is 2 plus 3 into 5 minus 1. So following this pattern, right? What if we take it all the way down to the nth term? So that simply means for the nth term now, you can see 2 is the first term. So we have A1 plus 3 is the common difference, as you can see. So here you see, this implies that the first term is 2. Okay, and the common difference is 5 minus 2, or 8 minus 5, and that is always 3. Okay, so now it means you have A1 plus the common difference times 5 is the n minus 1. So we can rewrite this as A1 plus n minus 1d. So we can conclude that, therefore, the nth term the nth term of an arithmetic sequence, the nth term of an arithmetic sequence can be obtained using the formula an equals a1 plus n minus 1 multiplied by d. So this becomes the formula for looking for the nth term of an arithmetic sequence. Okay, now, before I take examples at all, let me take another very important part so we can take examples jointly. So the formula is really important. Now, let's go ahead to talk about sum. The sum. So let's talk about, okay, I think I want to change this at this point. Sum of the first n terms of an arithmetic sequence. Okay, that's what we want to discuss in this case. Some of the first n terms of an arithmetic sequence. Now, imagine that you have an arithmetic sequence and you want to add maybe up to the fifth term, up to the 20th term, up to the 100th term, anything. So that is what we want to do. In this case now, of course, you know that generally speaking, we have an arithmetic sequence to be this: an equals a1 plus a2 plus a3. I mean, a1 comma a2 comma a3 rather, up to an. That's what we have, right? So if you now want to talk about the sum, right? So it simply means that we have, of course, you already know to find an. Okay, maybe we shouldn't talk about that yet. So now we want to talk about the sum. So we want to find a formula. We want to find a formula for Sn, which is the sum of all the terms up to the nth term, right? So imagine we have Sn equals A1 plus A2 plus A3 plus all that plus AN. So we want to find that, right? So, we can write the sum this way. So this is the key thing. We want to find an expression for this. But the way to now to go with that is we can rewrite this expression. We are rewriting it from the first to the nth, right? We can also rewrite from the nth to the first. So let's do that. Rewriting, rewriting, rewrite, rewriting Sn from an to a1. Okay, so we have Sn now to be equal to an plus an minus 1 plus an minus 2 plus all that up to a1. Okay, so this is another expression. This is another expression. Now, the next thing is, imagine this is, if you call this equation 1 and you call this equation 2, for instance, what if we add equation 1 and equation 2? What are we going to get? So that means that Sn, we have Sn in green plus Sn in blue, and that is equal to, then we can now add term by term, this term and this term, okay? This term and this term, this term and this term, this term and this term, up to this term and this term. So let's see what that looks like. So we have A1, we have A1 plus AN like this. Then, okay, I think I'm making it really hard for myself. So A1 plus AN, okay, then plus A2 at the top there, A2 plus AN minus 1, okay, that is A2 plus this. Then next, A3 plus AN minus 2. So we have A3 plus plus okay, A3 plus AN minus 2, and all that down to the last, AN plus A1. Okay, so we have AN at the top, AN plus at the bottom, A1. All right. So in this case, we can see that if we sum these two together, this is like 2Sn. Now, imagine that this is A1 plus AN. So you see A1 plus AN here. This is also A1 plus AN. Now, if you check properly, you discover that even all these expressions are technically A1 plus AN. What does that really mean? If you take if you take two, if you make n minus 1 to be equal to 2, okay? Uh so for n minus 1 equals 2, it means you have n equals 2 plus 1. Okay. Let me do it this way. Okay, so you have A2, AN minus 1 and all that, right? So you see that you observe that each pair sums to A1 plus AN. So if you sum everything together, you discover that everything is still A A1 plus AN, even all these expressions like this. Um, so A1 plus AN. There's a logic I'm trying to put forward. So that at the end of the day, A1, this is A1 plus AN plus This is A1 plus AN. All right. Then the next one is also A1 plus AN up to the nth one, which is also A1 plus AN. So that's what that is going to be. So at the end of the day, you have um you have finished two. So you have 2SN to be equal to N in so A1 plus AN in N places, basically. That's what we have. But you need to remind yourself that remember from what we found the other time, remember that AN is actually okay. So I mean, this is a good enough formula, right, for the sum. So so you can have it this way, and then this is the same thing as that Sn is equal to n over 2 into A1 plus An. So the first term plus the last term multiplied by n divided by 2. So this is a good enough formula. So we can use it in this form if we need to. Then another part is we can keep on with it and say something like this. We have we remember that an from what we found the other time is actually the first term plus n minus 1 d. So if you remember this, uh, right, and and substitutes, substitute into Sn equals n over 2 into A1 plus An, right? So that means we have Sn now equals n over 2 into A1 plus An now is A1 plus n minus 1 multiplied by d. So again, Sn is equal to n over 2 into A1 plus A1 is 2A1 plus n minus 1 d. And this is what we have. So uh therefore to find the sum to the nth term, find the sum to the nth term of an arithmetic sequence, the sum to the nth term of an arithmetic sequence. All right. Um, we use we use either Sn equals n over 2 into first term plus last term. All right. Or Sn equals n over 2 into 2A1 plus n minus 1 D. Yeah, so these are the two formulas we can use for that. Okay. These are the two formulas we can use for that. Okay, let's take an example to drive home the point. Let's take an example like that. All right. So example. Okay, let me change this to the blue. So example, given our popular AP, sequence, given the sequence 2, 5, 8, and so on. I mean, with two terms you are good, or with three, it's more convincing. So given the sequence that, so question, find one, the, okay, or let me say find the one, fifth term, okay, two, uh, the sum to the fifth term, three, three, say, let me just go to the 101st term. Okay. Four, sum to the 101st term. Sum to the 101st term. Okay, let's deal with this. All right. So now, of course, from what we have already, right? Let's go for the solution. So we want to do a check. at least we can do a check for the fifth up to the fifth term. So the AP can be written as 258. You don't really have to do this, but I just want to stretch it. So 258, 11, 14, 17. So this is 1, 2, 3, 4, 5. So this is the fifth term. And then if you sum up to the fifth term, oh okay. Uh yeah, let's just solve it first and then we can do that, okay? To avoid confusion. So let's just go. Um all right. So we need to find the fifth term. So one, to find A5. That's what we are looking for. To find A5, we already know that A1 from the sequence, the first term is 2. The common difference is 5 minus 2 or 8 minus 5, which is 3. Then to find A5, right, n is equal to 5. And we know that an is equal to A1 plus n minus 1 multiplied by d, basically. And then that means that A5 would simply be A1, which is 2 plus 5 minus 1 multiplied by d, and d is 3 in this case. So A5 is equal to 2 plus 4 times 3. Okay, so that means that A5 is equal to 2 plus 12. So A5 is equal to 14. And we have that settled. Okay, now what I wanted to do before, a kind of check. So you have 2, 5, 8 plus 3, 11, plus 3, 14. That is 1, 2, 3, 4, 5. So this is actually A5, correct. So to find the sum, to find S5 now, so this next thing is to find A5, to find, I mean S5. Okay, to find S5, we know we can actually have that Sn, we know Sn is either n over 2 into A1 plus An. Okay. In that case, that'll be S5 equals 5 over 2. S5 equals 5 over 2 into A1. A1 is 2, the first term. Now, of course, notice S5. Okay, let me just generalize first of all, right? You know, S5 will be 5 over 2. Okay, yeah, let me just go. 5 over 2 into A1, which is 2. And A5, we found A5 to be 14. A5 is 14. That is because we know A5. If we don't know A5, we cannot use this formula. So S5 is 5 over 2 into 2 plus 14 is 16. Okay. So that means S5 is equal to 5. 2 here is 1. 2 here is 8. So that's 5 times 8. So S5 is 40. Okay. S5 is 40. So let's check that. We have 2, 5, 8, 11, and 14, which is the fifth term. So 2 plus 5 is 7. 7 plus 8 is 15. 15 plus 11 is 26. 26 plus 14 is 40. So this is actually correct as S5. Okay. Now, what if you don't know the fifth term? Because you don't have to find the fifth term to get what we have just obtained. So another thing you can do is to say Sn is n over 2 into 2a1, 2 times the first term, into n minus 1 multiplied by d. So again, we know a1 to be 2, we know n to be 5, and we know d to be 3. So in case you don't know the fifth term, so you can actually use this formula. So S5 now is equal to 5 over 2 into 2 times 2, that's 2a1, into 5 minus 1 times 3. Okay. So S5 will now be 5 over 2 into 2 times 2 is 4 plus 5 times 4. I mean 5 minus 1, that's 4 again times 3. Okay. So you multiply that first. So you have S5 equals 5 over 2 into 4 plus 4 times 12, that's 4 times 3, that's 12. So we have S5 to be 5 over 2 multiplied by 16. So 2 here is 1, 2 here is 8. So again, S5 is equal to 5 times 8, and S5 is equal to 40. Okay. So I leave you to do this other two so I can do something of the negative type. So practice. So you want to practice these two. Okay, practice these two. So let me take a sequence that is decreasing, not increasing like this other one. So let's take another example. So we can take that one as example one. Did I call it example one previously? So this is example one. So let's take example two. So example 2. Example 2, find 1, find the 1/7 term. 2, sum to the 7th term. Or okay, it doesn't have to be this, right? We can say sum to the 11th term. Let me just switch it up. Okay. Of the sequence, say we have where do we start from? Let me start from 100. So 100 minus 7, that's 93. 93 minus 7, that will be 86, I believe. Is that? Yeah, 86 plus 7 is 93. So this is the sequence we have in this case now. Okay. So let's go for the solution to this. The solution, what's the first thing we need? We need T, we need the 7th term. That is A7. We need A7. That's what we need. So, and we know that AN generally, in this case, we don't know the last term. So, I mean, we are looking for the last term actually. So, and the formula is simply A1 plus N minus 1D. So, based on this formula now, we know N is equal to 7, A1 is equal to 100, then D is 93 minus 100, or 86 minus 93. And that is simply minus 7. The minus is really important because it's decreasing. So minus 7 is the common difference here. And if that is the case, we can then bring, we can then find what we need to find. So A7 now will simply be A1. A1 is 100 plus N. N now is 7 minus 1 multiplied by minus 7. Okay, so that A7 is equal to 100 plus 7 minus 1 is 6. 6 times minus 7 is what we have now. So A7 is equal to 100 minus 6 times minus 7 is minus 42. And then A7 would be 58. Okay, A7 is 58. Can we check if that is correct? So now just bring that expression. We have 100 minus 7, 93. 97 minus 3, 86. 86 minus 7, that's like 78, I believe. Yeah, is it 78? No, that should be 100 minus 7, 93. 93 minus 7, 86. 86 minus 7, that is 79. 79 minus 7, that is 72. Okay, 72 minus 7. 72 minus 7, that is 65. 65 minus 7, that's 58. Okay, so 58 plus 7, 65. 65 plus 7, 72. 72 plus 7, 79. So this is 1, 2, 3, 4, 5, 6, 7. So this is actually A7 indeed. Okay, so the next part is to find sum to the 11th term. Okay, sum to the 11th term. Okay, so we have number 2 now. We want to find S11. We want to find S11. That's the next thing we need. Interestingly, we don't know A11, so we cannot use the first formula since we don't know A11. So, but we know we can use Sn equals n over 2 into 2A1 plus n minus 1D. Okay, we can use this for sure. So, again, we know that A1 is equal to 100 from the series we have. Of course, I guess we can always write that. So we have 100, 93, 86. That's what we have. So the first term, A1 is 100. Then our N in this case is 11. Okay. What else do we need? We need a common difference, which we already know to be 93 minus 100. That's minus 7. So in that case, we can find S11 to be 11 over 2 into 2 times 100 plus 11 minus 1 times minus 7 times minus 7 like this. So S11 is equal to 11 over 2 like that into 2 times 100, that's 200 plus 11 minus 1, that is 10 times minus 7 like this. So we have S11 to be 11 over 2 into 200 plus, okay, 10 times minus 10 times minus 7 is minus 70. Okay. So we have S11 is equal to 11 over 2 into 200 minus 70. So that S11 is now 11 over 2 into 200 minus 70 should be 130, I believe. Yeah, 130. So S11 is equal to 2 here is 1, 2 here is 65. So 65 times 11, 65 times 11, that is 5, that is 6, this is 5, this is 6. So this is 517. Okay, so we have 715, and that is the sum to the 11th term, which we can also check, right? This is the 7th term. So you can just write it out and add up. You see the result will be 715. All right. So to close this out, let's talk about some applications of arithmetic sequence in our daily lives. Okay. Applications of arithmetic sequence in real life. Okay. In real life. So of course, first we have it in finance. We have sequences in finance where we talk about arithmetic sequences are used to calculate loan repayments. Okay, so say loan repayments, loan repayments. Okay, where the amount paid increases or decreases by a constant amount each period. We can even talk about say what's this thing called when things lose value. Okay, when things lose value, we can also use that. I'm trying to remember. Yeah, depreciation, right? Depreciation. So if things depreciate at a regular rate, okay, we can of course use that. Then we can have that in construction. We can use uh arithmetic sequences in construction. Okay. In construction, the spacing of beams, okay, spacing of beams, spacing of beams, for instance, can follow an arithmetic sequence, beams, trusses, or tiles. Okay. Uh, Spacing of tiles, or let me even say tile patterns. So when you're laying tiles, so the patterns can follow an arithmetic sequence. Say tile patterns. Then number three, we can talk about it in sports, right? Sports. Imagine a player might score a certain point per game with a constant increase or decrease. Okay. So uh calculation of points, the sports can actually follow that kind of pattern. Then now imagine in travels, right? In travels, if you're traveling a constant distance every day, the distance covered over time forms an arithmetic sequence. So, say distance traveled can form an arithmetic sequence. So with this, we come to the end of this video on arithmetic sequence. So after now, we're talking about geometric sequence in this kind of detail too. So if you have not subscribed to this channel, you want to do that right away so you don't miss out on that. You also want to hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment. Let me know how helpful these videos are. You also want to let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. Then you want to like and share so that more people can have access to this great content. Till I come your way again, do have a great time. Bye.